Our next speaker is a gentleman with whom I'm personally acquainted, Mr. Ken Klein, who is Director of the Office of Energy Storage and Distribution of the Department of Energy. In this capacity, he is involved in research activities in electrochemical storage, thermal storage for industrial and utility applications, hydrogen production and storage, superconducting, and electric field effects on humans exposed to high voltage, which brings us to the reason he's here. Ken is a graduate of Purdue University, has worked for the Cleveland Electrical Illuminating Company in a variety of capacities. He is a senior member of the IEEE and has been quite active in committee affairs, among them Distribution System Design Distribution Subcommittee. He's also a member of the U.S. Technical Committee of SIGRI. The topic of his presentation will be electromagnetic research at the Department of Energy. Ken?
Well, here stands before you a bureaucrat that came from the East Coast all the way to West Coast to talk to this large congregation of people, and I'm not running for election. So with that, let's start the flow of these slides, shall we? As Marv said, we're going to give you a bit of an update on how we've been spending your tax money. We've been doing this for about, a little over a decade now. And I think the thing that we have brought to this technology is maybe somewhat different than others, and yet there's common threads through all of it. This being the largest program total, we've had a chance to lead the way in certain aspects of this kind of research. One is that we feel, being a government agency, it's incumbent upon us to do unbiased research, to come to the table without preconceived notions, to do high-quality research. And in fact, we have a quality control team that goes to each one of our locations before we begin research to make sure they know what they're doing, they know what they're measuring, and in fact, the dose can be verified. And then we recheck that as the research continues to make sure that the research people that are involved in it have adequate control to make certain that those conditions remain. And finally, our duty is to give the research results out to the community. We are not regulators. We are researchers who are involved in this kind of research for the sake of being able to let the community know what it is we have found. And in that regard, our program has the goal of safeguarding public health, ensuring the efficient power supply for the nation's networks. And you might relate to that directly by the fact that how many transmission lines do you know of that are held up in court for many, many reasons. And finally, our real motivation is to provide an information base through research. Biological research is the epitome of Murphy's Law. If anything can go wrong, it not only does, it has, and it will continue to go wrong. And when biological studies are made, it is incumbent upon us to make sure we can replicate everything that we do in such a way that we eliminate the possibility of drawing erroneous inferences from the work that we do. Now, as you know, there's a lot of misinterpretation and confusion in this whole field. I wouldn't say that the press purposely comes up with erroneous results that are confusing to the public, but nevertheless, because they are not of the technical nature and this is a highly complex field, it is very easy to misinterpret that which is going on in this kind of a field and draw conclusions that are made up of short statements out of context. So there's a great deal of confusion. There are also a lot of lawsuits, as you know. There's seems to be a result of this is a case-by-case resolution of the problems rather than any standardization over a large area, a region, or the nation. And there seems to be contradictory data, as you can see from the presentations this morning. While the Department of Energy does not have any epidemiological studies, we must admit that we take cognizance of all of them. There are several dozen of them. They may be leading indicators, as we keep hearing month after month, leading indicators of the economy. Maybe these are leading indicators of the work in which needs to be done in this field. You've heard about the occupational epidemiological studies, the residential ones. You've heard the fact that there are risk factors that are very close to being irrelevant. In other words, the risk factor is not high enough to be taken seriously. We don't know whether there's childhood leukemia because there's so many small numbers of cases that have been run in these areas, and also the poor ability to be able to characterize what is really going on in these exposures. There are some ongoing epidemiological studies that we hope will be adding more information to us. The Seattle data, which was the data which was produced on industrial workers, is being re-examined. More work is needed in this area, but it's underway. There's a Canadian study that they're doing with the French. There's also childhood cancer studies that EPRI is doing in the Los Angeles area. All of these need to have a great deal more work done so that we can, in fact, determine whether there is something here that is an indicator of the direction in which more specific cell, tissue, and whole animal research should take. I'd like to tell you now about a few kinds of the research in which we have been involved that I think will be of interest to you. For example, we are doing work with some humans, exposing humans to both electric and magnetic fields at various electric field intensities and various magnetic field intensities. The interesting part of this is that it isn't consistent. Now, that's a surprise to you, I'm sure, for hearing everything you've heard this morning. We expose humans to 9 kV per meter, and we get an effect. We expose the humans to 12 kV per meter, and obviously that is a greater impact on humans. Not so. The effect goes away. These are healthy male subjects who have volunteered to do this work. Most of them are medical students, and as a result of the exposure to the electric and magnetic fields, we have them perform certain tests, physiological tests and psychological tests, and see how they perform over time. And also taking the blood fluid analysis, we can tell what is happening to their chemical systems. We find 2 things. One is that there's a heartbeat reduction, and secondly, there's a brainwave amplitude increase. Now, if you join me in taking one deep breath, that's about the difference in the heartbeat rate that we noticed. If you drank a cup of coffee this morning, that's about the brainwave level that we noticed differences. Now, I'm not trying to say that those are irrelevant things. I'm just saying that there are some subtleties in this research that have to be very carefully analyzed, and it can't be done in a very cursory, carefree way. It has to be done very, very carefully. I thought you might like to see what one of these places look like. Here's a student in a room that was built, a very pleasant-looking room. He is exposed to both the electric and magnetic fields. In one series of tests, since these were all male students that were doing this, we noticed in the mornings they were getting a strange occurrence. And it wasn't until the researcher noticed that the research assistant that was doing the preparation of the male student was a very lovely young lady. And this lasted into the reaction lasted into the test period, and so quickly converted that to another type of gender. Fortunately, these students weren't affected by that. I mentioned that at 9 kV we found an effect and at 12 kV we didn't. There was also some other interesting things. There's a morning-afternoon difference that we still have not been able to explain. You can tell this is just a cartoon of the morning and the afternoon, but if the effect is vertical, increasing effect vertical on the axis, you notice that in the mornings we got a continual increase in the effect as time went by, but in the afternoons when the second part of the test took place, it decreased rather than increasing. This is not understood at all. In fact, the fact that there was a window at 12 kV that said the effect went away is also of concern to us. So we are redoing these tests to try to find where we were careless, if that in fact is the case, in being able to have the control over these tests that would indicate why we saw some things and other times we didn't see them. So we're going to be redoing these not at only 6 and 12 kV, but we're going to do an intermediate one at 9 kV. We also have some primate studies going on, and this is a study which we're in cooperation with Japanese agents, an organization which is called CRIEPI. It's a counterpart of EPRI in Japan. They are funding this work here in the United States at one of our laboratories, in which we take baboons and we do both social and operant tests on them. They are exposed to 30 and 60 kV per meter, and for this first test it was only electric fields, and the tests were short length of 6 weeks. We found short-term transient responses, and we found, though, that in a period of about 3 days, the baboons ignored the turning off and the turning on of the electric field. It's interesting, we have a video of the first time a cage of 8 baboons, so then that's a social cage, the first time the electric field was turned on. They acted like they had just been surrounded by Indians. They were very active for a period of 10 minutes or so, running around the cages on the top of the upside down on the top of the cage to the walls, back and forth, finally circling themselves, everyone looking out to see where the threat was coming from. And after the second or third day, the habituation was total. They totally ignored it, and there was no interaction from then on. Now, as a process of continuing this, we have gone to a second phase of this, which the Japanese have just signed off on a couple of weeks ago, in which we are going to be taking this research one step further. I mentioned the social cage. This is one in which they're pretty well scattered out along the social cage. And what we're trying to do at this particular point of finding out, is there a difference in the social behavior of this group of 8 baboons who have become accustomed to each other over a period of a year or more, so that their social structure was determined before they were put in here, and now they're put in here, and now they have to deal with the electric field. So what we will be doing is, in the same cage situation, we will be adding a magnetic field component to it for our next series of tests. Also, we do some of the tests on how well they can interact getting food or doing tests. And there's a series of trained things that they do when they get certain signals. And this is a baboon who is operating those tests at this particular time. We will also be adding a magnetic component to this test, and we'll be extending them so that we will have longer-term exposures up to 18 weeks. And we'll be doing the same kind of endocrinology and behavior tests that we were doing before, so we can try to correlate some of these things. Now, I mentioned that the dose is fickle. You notice the top cartoon. There's a dose that goes on, and then it tapers off. And then as the animals acclimate to it, there is no further paying attention to it. Even the fact that we leave them out of a field for a period of time and then bring them back in, they don't seem to worry about the fact that the memory is there, that this is not a real threat. And so our phase 2 will be including different exposure levels for electric and magnetic fields, as agreed upon by the department and the Japanese people. We will be adding the magnetic component, and we will be doing an 18-week exposure. Some of the other things that have happened over years is that people have said, well, this is just a stress. Electric fields are just a stress on the people, and therefore we ought to test that. We had a group of people at the University of Rochester that looked at stress from the point of view of monkeys, and they had done a lot of work preliminary to our tests in looking at what happens when a monkey is shocked, foot shock. And here they could tell a chemical difference in the reaction of a monkey after being foot shocked. However, when we did the tests on electromagnetic fields, we could find no stress hormones within that animal. However, in the New York State program, Kurt Sullinger did a test on rats in which he exposed both electric and magnetic fields from conception to 8 days after birth. And at 90 days, he found that there was a change in the memory capacity, and it had been significantly reduced. Again, something that has not been replicated. We're not looking at this as a red flag yet, but there is a concern as to whether is this something that if we had long-term exposure, not only to rats but to humans, would we have loss of memory? This may be an excuse for some of us that at times, but it never affected me very much. Another test which we have done for a number of years is looking at the regular cycles of a body, the circadian rhythms. We know that the mental acuity can affect us when we travel long distances and get jet lag, and that is very similar to what we might say is causing the concern in this area. And one of the concerns that we have here is what happens with shift workers in the utility industry when they go from one shift to the other. Do they lose that sharp edge that will allow more accidents to occur or whatever? So we are looking at not only that, but at the immune system to see whether the immune system is degraded by the fact of circadian rhythms, or whether there are other effects that can surface that would give us an indication of whether this is something that we should be vitally concerned about, or is this just something that is a transient that really has no relevance on a long-term basis. Pineal gland is another area. It's a little gland in the brain about the size of a pea that controls some of the hormones in the body. We know that from previous tests that were conducted before we were involved in this and by other agencies, that removal of the pineal gland promotes cancer. Its essential hormone is melatonin, and this is something that is affected by how the pineal gland impacts the body. And this is, in effect, a dark and light kind of effect. In fact, we came across this effect in a rather strange way, and how sensitive it is, in a strange way, in that we had a malfunction of our test facility. And all of a sudden, this very robust effect went away. And a great concern to the researchers as to why all of a sudden did something go away. And finally, the research investigator went inside the cage area, stayed there until he could totally acclimate himself in the dark cycle, and found that there was a pinhole of light that was getting into in the test facility. And just that pinhole of light was enough to affect this. Well, again, one says there's a lot of light on as we're doing our business, even at night. Is this something that we really ought to be concerned about? I don't think we can say yet, but it is a robust effect, and one in which I don't believe we can ignore. We've noticed these effects from all the way from 1.9 to 135 kV per meter, so it is a widespread. We've noticed that tumor-enhancement studies have been relatively inconclusive, but yet there have been some subtle indicators. We're interested in following the electric blanket study that EPRI is doing to see whether that is going to have any impact on this. And all of these together may start putting a picture together that will help us. I thought you might like to see a a picture of one of the test facilities that we have. Here there are a number of cages of mice that are being tested in 3 rows. There are some of them, there's a ground plane as well as an energized plane in this, and across the room, identical to this, absolutely identical to this, would be the control, where nothing is energized. And in fact, the researcher would not know whether this particular group of animals that he or she is dealing with are in the exposed or the unexposed one. So we call that a double-blind study. And those are the ones we try to run most often. We feel much more confident with a double-blind study than we do when the researcher knows which animals have been exposed and which haven't. We have to eliminate as much as we can from supposition and get down to the real facts. Now, this is another one of the cages that have been used for mice. Mice are easy because they have a rather fast lifespan and they're relatively cheap. Bunny rabbits are different. Dr. Adey gave you a great deal of information about cell physiology, and I'm only going to say that with the electric and magnetic fields, we're exploring this field-cell interaction. It looks to us as though the electric and magnetic fields have the potential of showing us something in this area, maybe as precursors to what might be happening on the whole body. Let me just review for a moment, though. When you talk about ionizing radiation, remember that this is like a bullet going through and tearing something off of a tissue. Microwave, on the other hand, that frequency is more the cooking of that cell. It's heating it up to the place where it is killed. On the other hand, electric and magnetic fields, the 60 hertz and DC things, interact with membranes in a very subtle way that may not be obvious to us either in a short term or in many of the studies that we've done as to what is really impacting across that area. We do find there's increased cell metabolism. There's reduced killing ability with the lymphocytes, it's the white blood cells, and there's some neuron actions that are not always understood. You saw this before. Dr. Adey showed you this in a whole series of them. I just want to point out that between the 3 cells that have been injected with this dye and been color enhanced in this picture, there are other cells which did not illuminate. And it indicates that all of a sudden the cells have lost their ability to communicate with each other. And we have noticed in our studies that when cells lose that ability, they don't know that there's somebody next door to them. And so they continue to build new cells, not recognizing that there's a cell already occupying that area. And so you get compounding of this in 3 dimensions, because when a normal cell comes up next to another normal cell, they immediately communicate and it says, don't build another cell there because I've occupied that space. But in the case of cells that have had this cancer material interjected into them, and then they're exposed to an electric and magnetic field which promotes the growth, we feel that this might be an indicator to us as to where the problems in the future may in fact lie. Some of the work which has been done in the past has been excellent. Some of the work that is, and this is not work which has been done at the Department of Energy, but I just point out that there are people like Reba Goodman who are doing excellent work in the problems of gene transcription and translation. And in Sweden, Dr. Mild is doing some good work in chromosomes. We're watching this work carefully to find out whether they, again, can tell us what are the problems that we ought to be looking at in our more detailed research. So we are doing work in membrane mechanisms. We're looking at phase change transitions. We're looking at cyclotron resonance, which is a complicated study in which we look at not only frequency but intensity and a whole array of other things and especially where there are certain ions that give us certain qualities of our body health, lithium and calcium. And some of these have to be very carefully analyzed, because if we're impacting those critical ones, it may be emphasizing something that is causing difficulty for the whole body that might not be obvious to us on the surface. So what are our future directions? Well, we certainly are going into looking much more carefully at magnetic fields. We're not ignoring the electric fields because there may be a synergism between them. We have to find that out. Looking at long-term effects, especially that with cancer. And we're looking at cell membranes, trying to find, is there a critical participant in this whole thing? We don't draw conclusions in this work that we do, being a federal agency. What we try to do is to do as good a research as we possibly can, and then let the people that need to draw conclusions from it do it from the best possible database that we can provide. But we do know that there are definite biological effects. But so far, we can't really say with any certainty that there is a biological hazards, or to at least to what degree the hazard might be. There doesn't seem to be any reason for regulatory action at this point on a federal level. Our friends at the Environmental Protection Agency, which would be the ones to do it if there were, because the Department of Energy is not a regulatory group in this sense, this is very, very low on their priority of things to regulate. So I don't see that happening, but we do notice an increased activity among states. And in fact, a number of states are now sort of following the direction that New York State did and providing funds to do research in this area. And we hope that we will be able to assist them and be able to do this even better. There is no alarm at this moment, but we at the Department of Energy have a deep concern over where the impact of this might lead us. It sort of makes us stop, though, periodically and say, let's not draw premature conclusions. They may be wrong. It reminds us of the story that we heard a few weeks back of the minister who was preaching his Sunday morning sermon, and this happened to be the part of the sermon where he was talking to the children. So he had gathered the children around him at the front of the sanctuary, and he looked at them over eye to eye, and he said, "Tell me, boys and girls, what is it that's brown, has a bushy tail, has 4 legs, eats nuts, and climbs trees?" No response. Nothing at all. So he asked the question again. He says, "You must know what's brown, bushy-tailed, has 4 legs, eats nuts, and climbs trees." He looked down to one of the little boys, and he said, "Joe, don't you know what that is?" He said, "Preacher, I know the answer you want is Jesus, but it sounds like a squirrel to me." We're trying to not preconceive what the answer is in our studies. I hope we're successful, and thank you for your attention.